In this question, again, this is a RC based time constant question, right? And in this question, again, we need to calculate the voltage across capacitor and the current across capacitor. And I told you, whatever, whenever, like whatever value they'll ask, if they have mentioned capacitor, you always need to calculate voltage across capacitor. If there is a RL circuit, then you need to calculate current across inductor, right? So, but they ask you the current across capacitor also. For that, there is one formula, C dVc by dt. Okay, Vc value we already know, we just need to put it. Now the next question is, how can we calculate Vct? For that we are having formula, that is Vc of infinity plus Vc of 0 minus Vc of infinity e raised to power minus t by tau. Okay, Vc of infinity is the final, right? Vc of 0 is the initial minus again final, that is e raised to power minus t by tau. Like you can remember it like that, like your final aim is to become an engineer, right? First you think what is your final aim, then you started from the initial condition, that you started from the first year, again you go back to your final aim. Like this you can remember, first final you have to see, then initial minus final. Okay, for this we need to calculate value of Vc infinity, Vc 0 and tau, that is time constant, right? So we have to see at t equal to 0 minus, switch is connected to A or B, tell me. 0 minus, it is connected to B, and at t equal to 0 plus, switch is connected to A, and at t equal to infinity, switch is connected to A only, correct? So now move to our first step. Step number 1, we have to draw the circuit for t equal to 0 minus, right? So at t equal to 0 minus, which is connected to B, right? We just need to connect this part only. So I'm redrawing the circuit. There is a capacitor and then a resistor, then a voltage, right? Capacitor value, resistor value is 60 ohm, 20 ohm and 40 volt. This is plus minus Vc. Now I told you that at t equal to 0 minus, this is the condition of steady state. So at steady state, capacitor is going to be open circuit, right? So I'm removing this. Now at this particular condition, we need to calculate Vc of 0 minus, that would be equal to Vc of 0 plus, that would be equal to Vc, that would be equal to, I am telling you, always mark A point and B point, right? So that would be equal to VAB. Now our aim is to calculate VAB simply. Again I told you, just mark point here like A. Now tell me, what can I write down? VAB would be equal to VAC plus VCD plus VDB. So VAC would be equal to 0. VCD is how much? ICD, RCD, VDB is 0. RCD we already know, 60. But for current we have to apply KVL, right? You are moving from C to D, so current should also move from C to D. Then we can mark the sign over here, right? Now we have to take the second step. Like you are standing at E position and you have to back to E only. Now can you tell me the KVL equation? Minus 60 ICD minus 40 minus 20 is equal to 0. So if we'll solve it, what would be the value of ICD? We got it minus 80. Then we got it as how much? Tell me. Minus 0.5. So we can mark it here 0.5 with the negative sign. What would be the value of VAB? Tell me. That is minus 30 volt. Okay. If you come across with the minus value, you have to write down minus only. Okay. Now move to step number 2. Now tell me what was step number 2. At t is equal to infinity. At t equal to infinity, that is again for the steady state, right? Now for the steady state, again capacitor will behave as a open circuit. So at t equal to infinity, now the switch is connected to A. So we have to redraw the diagram again. So the diagram would be like this. Here capacitor was connected now. So now B is disconnected, so we don't need to draw this diagram. Okay. So again capacitor will behave as an open circuit. Again I am removing. We have to mark A and B. This is 90 volt. This is 400 kilo ohm, right? Again we need to calculate V infinity. That would be equal to VAB, which is equal to 90 volts because no current is flowing across 400 kilo ohm. So VAB would be equal to 90 volts. Clear? Now move, we can put down the values also here. V infinity we got it as how much? 90 plus V of 0, how much we got it? Minus 30. Okay, I told you put minus 30 as it is. Minus 30, then minus 90 e raised to power minus t by tau. We need to calculate time constant, that is equal to tau. Remember I told you the steps for the calculation of time constant. We have to draw it at t equal to 0, transient condition. Current source should be open circuit. Voltage source should be short circuit. We have to calculate total resistance and we have to mark A and B where C is connected. Correct? Now at t equal to 0, as you can see the circuit also, t equal to 0, switch is connected to A. So again I told you voltage source must be short circuited. So I am doing short circuited. We have to mark terminal A and B where resistance is connected. That would be R equivalent, and R equivalent here is 400 kilo ohm. Now we need to calculate tau, that is R equivalent multiplied by 400 kilo ohm multiplied by C is 0.5 microfarad. It is going to be how much? 200 seconds. Correct? We can put it here. I'm putting like 200 seconds. Clear? Wait. There is some calculation mistake. It is kilo and it is micro. Micro would be into 10 raised to power minus 6. Kilo is 10 raised to power plus 3. So answer is it in to how much? 10 raised to power minus 3. It would be 0.2 second. Okay? Yeah. See, simple mistake can let your marks down, right? So we got it. If we'll further solve it, we'll got it as 90 minus 120 e raised to power minus 5t volts. Correct? Now in the question, what we need to calculate current across capacitor, right? So current across capacitor is how much? C dVc over dt. C is given 0.5 microfarad. D by dt of differentiation 90 minus 120 e raised to power minus 5t, right? Now you can simply solve it and then you will get the value of 300 e raised to power minus 5t microampere.